Good morning, students. Myself, Ashutosh Pawan, Faculty, Department of BCA, Harprasad Das Jain College, Ara. In today's video lecture, I am going to illustrate the concept of break jump statement by making a program using C programming language. In my previous video lecture, in which I have taught you the theoretical concept of using break jump statement, I have taught you that break statement is used with switch case selection construct, and it can also be used with loop constructs. I have taught you that when break jump statement is used with switch case selection construct, it directs the flow of execution outside the switch case selection construct body, and when break jump statement is used with loop construct, then it directs the flow of execution outside the loop construct body. I have also taught you that you have to keep two key points in your mind while using jump statement in C language program. These two key points are: the jump statement are always used within the condition body, and the second key point is the jump statement must be the last statement inside the condition body. So I am going to illustrate by making a C language program how break jump statement directs the flow of execution outside the loop construct body when it is used inside the loop construct body. For this, I have to launch the C program editor window in the screen, and I am going to launch it in the screen. First of all, I am going to write the question in which I will make use of break jump statement. The question is, the problem for which I am going to make a C language program is write a C program to print whether the number is prime or not prime. This is the problem for which I am going to make a C language program. Well, as you know that I have to include the header file by using the preprocessor directive #include, and the header file that I am going to include is stdio.h. I am going to include this header file because I am going to use printf and scanf function in this program. And as you know, during the runtime of the program, the compiler directs the flow of execution inside the main function body, and I am going to define a main function in this program. I have written the return type of this main function as void because I am going to return nothing from this main function body, or in the other word, I am not going to return a single value from this function body. The first phase of solving a problem is the declaration of variable, and to solve this problem I am going to declare three variables. One is named num, second is named divisor, and the third is named as flag. You can give any name to your program variable. I am giving my variables name as num, divisor and flag. Now I have completed the first step of solving a problem, and I have entered into the second step of problem solution, in which I have to perform the value of required variable task, and for this I have to take an input of the number that is to be tested whether the number is prime or not prime. Hence I am going to print a message using the printf function, enter your number. This message will be displayed at the screen during the runtime of the program, and for this message the user has to input a number, and when this scanf function will be executed, the user will be prompted to enter a number, and the number entered by the user will be stored at the address of the variable num. Now, as we know that a number is prime when there is no divisor of the number except 1 and the number itself. This means that if there is no divisor of any number except 1 and the number itself, then we can say that the number is prime. So we have to check that any number except the number and 1 divides the number or not. For this I am going to initialize my variable divisor with the value 2. I have to leave the value 1 because the value 1 is the divisor of all numbers, and hence I have to check the divisibility of the number input by the user by starting with the number 2 and ending at the number minus 1, because we also know that the number itself is the divisor of the number. Now I have initialized the variable divisor by 2, and I am going to initialize the variable flag with the value 1 by assuming that if the flag remains 1, this means that the number is the prime number, and if the flag value changes to be 0, I will do it later in the program. If the flag variable is set to be 0, this means that the number is not prime. Hence I have performed all the necessary steps to perform value of the required variable task, and now I have entered into the third phase of solving the problem, where I have to perform the calculation, and in this program I have to perform the calculation using the loop construct. I am going to write the while loop construct in this program, and with while keyword I have to write the condition. I am going to write the condition here: divisor less than equal to num minus 1. I have to perform the division operation by starting with the value 2 and ending at number minus 1. Hence I have written the condition with while keyword: divisor less than equal to num minus 1. Now I have to check the divisibility of the number by the divisor. For this I am going to write the condition: if number percent divisor equal to 0, if the value of the variable divisor divides the value of the variable num and the remainder is obtained as 0, this means that the value of divisor variable is a value that divides the number completely, and hence we can say that the number is not prime. Hence I am going to set the value of flag variable with the value 0, and once a divisor of the number is found, then there is no need to perform division operation, and we can say that the number is not a prime number. Now we have to perform the new value task for the variable that I have used in the condition with the while keyword, and I am going to increase the value of the variable divisor by 1. Now the body of the loop has been closed. Now we have to check the value of the variable flag. If the value of the variable flag is exactly equal to 1, then we can say that the value or the number is a prime number. I am going to print the message by using the printf function, and if this condition becomes false, then the flow of execution will be directed to the part else, and there I am going to print an output that number is not a prime number. Now I have completed all the steps of solving the given problem, and now I have to save my program file. I am going to save my program file by clicking on file menu and then clicking on save as command. I have to write the program file name. I am going to write the program file name as testprm.c. Now I have completed the first phase of program development, and I have entered into the second phase of program development, where I have to compile the program. For this I am going to click on compile menu and then click on compile command. As you can see that my program has been successfully compiled. There is no error or no warning during the compile time of the program, and thus I have completed the second phase of program development, and now I have entered into the third phase of program development. I am going to click on run menu and then click on run command. Now my program is now executing, and you can see that a message has been displayed in the screen. This is the same message that I have printed using the printf function, and I have to enter a number so that the scanf function in the program may execute, and I am going to enter a number. I am typing the number 7 and then I am pressing enter key from the keyboard, and now I have completed the third phase of program development, and I have entered into the fourth phase of program development, where I have to click on window menu and then click on user screen command. You can see that a message has been displayed as prime number, so 7 is a prime number. Now I am going to run my program again with a different value. For this I am going to click on run menu and then click on run command. Now my program is being executing, and here I am going to write a next number. Suppose I am going to write the number 8, and then I am pressing enter key from the keyboard. Now I have completed the third phase of program development, and now I am going to check my output by clicking on window menu and then by clicking on user screen command, you can see a message has been displayed as not a prime number. Hence we can say that 8 is not a prime number. Now I am going to illustrate how the break statement is directing the flow of execution outside the loop construct body. For this I am going to write a printf statement Now I have written a printf statement, and now I am going to save my program by clicking on file menu and then clicking on save command. This time I am clicking on save command because the modification made in the program is to be saved in the same file that I have already named testprm.c. Hence I am going to click on save command, and after saving the modification, then I have to compile my program again by clicking on compile menu and then by clicking on compile command. You can see that there is no error when I have compiled my program, and after compiling the program I have to execute it again. For this I am going to click on run menu and then click on run command. Now my program is being executing, and now I am entering the value 209. Now I have to check my output. For this I have to click on window menu and then click on user screen command. You can see that when the number 209 is divided by the divisor 2, remainder 1 has obtained. This means that the number has not been divided, or this means that the number 209 is not going to be divided by the divisor 2. And in the next line the output message states that 209 is not going to be divided by the divisor 3 because it is resulting the remainder 2. The number 209 is going to be divided by the number 11, and you can see that in the second last line divisor 11 has remainder 0 when 209 is divided. When 209 is divided by the divisor value 11, then it results the remainder as 0. This means that 11 is the divisor of the number 209, and when a number is divided by any divisor and when it results the remainder 0, then we can say that the number is not a prime number. You can see that the number 209 is divisible by 1, 209, 11 and 19. These four values are the divisor of the number 209, but we have to leave the numbers 1 and 209 itself, and we have to check the divisibility of the number 209 by other numbers starting from the value 2 and ending at the number 209 minus 1. You can also see that a number has a divisor between 2 and half of the number. So you can write the condition as y divisor less than equal to num divided by 2. Divisor less than equal to num divided by 2. If there is no divisor of a number between the half of the number, then you can say that the number is a prime number. So you can see easily that break statement is directing the flow of execution outside the loop construct body by skipping the statement divisor plus plus. This statement has been written inside the loop construct body, but when the break statement is encountered, this statement is skipped by the compiler, and when the number is not divided by the value of the variable divisor, then the statement divisor plus plus is being executed, and once a divisor value has been found that divides the number and results the remainder exactly equal to 0, then the body of the if construct is being executed and the value of the flag variable has been set at 0, and then the statement break is executed, which cause the flow of execution to be directed outside the loop construct body. This is the program that illustrates the use of break jump statement. And now I am quitting the C program editor window. I hope that you have understood the concept of break jump statement, and you have understood how to use break jump statement